Hello, good evening, everyone.
Good evening, ma'am.
Good evening, ma'am.
Yeah, so up to week three, you have studied about the discrete random variable, right? About their marginal distribution and joint distribution, how two random variables are independent, and how we find their expectation, variance, correlation, right? So all these topics we have covered up to week three. So in week four, we have to study from week four, we will start everything about continuous random variable. Okay, now let me share my screen. Yeah, is my screen visible?
Yes,
Yeah.
ma'am.
Okay. Yeah, so in week four, we have to study about the continuous random variable. So before starting the continuous random variable, let's take a quick idea about what is discrete and what is continuous random variable. So anyone would like to explain what is discrete and what is continuous random variable? What do you understand by discrete and continuous? Anyone?
Ma'am, discrete means on a particular point, and the continuous means understandable, like something covering the whole part of the area.
Okay, yeah. So discrete is something that takes distinct values on real line, right? And that is something we can count. And continuous is something which takes values in interval and it can take any value in that interval, right? So suppose if the interval starts from 10 and goes up to 20. So if the variable is continuous, it will be taking any value between 10 to 20, right? And that is something we measure. Okay, so suppose we have here in discrete variable, suppose we have values from 10, 11, 12 up to suppose 20. Okay, these are discrete variables. This is a discrete variable which is taking values from 10 to 20. And here it is a continuous variable and this is taking values from 10 to 20. Okay, so here it can take any value, right? And here it will be taking only 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, right? So similarly, if I take example of a die, so where suppose x is a random variable which represents the outcome of a die. So what values x will be taking here?
One, two,
One,
three, four, five,
four,
six.
and six.
1, 2, 3, 4, and 6, right? And if I have to find the probability, so what it will be? Like
One
occurrence
by
of 1,
six.
it will be 1 by 6. So for 2 also, it will be 1 by 6, right? So total outcomes are 6 and favorable is 1, so 1 by 6, right? Now, if similarly, if you find probability here in continuous case, so you know that total there are lots of points between 10 to 20. Infinite number of points are there, right? Okay.
Ma'am, can you explain the difference between them once again?
Okay. So discrete variable is something that takes distinct values on real line. Okay, so suppose we have a variable which is a discrete variable and it is taking values 10, 11, 12 up to 20. Okay, so it will not be taking values between 10 and 11, right? But if you have a variable which is continuous and which is taking values 10 to 20, so it can take any value in this interval. Okay, and between 10 to 20, there will be a lots of points. Infinite number of points will be there, right?
Yeah, thank you, ma'am.
Okay.
Yeah.
And discrete variable is something that we count, and in continuous something we measure. So these basic things you have studied in statistics one course, right? So here I have taken an example of die. So similarly, if we have to find probability, suppose we have a random variable which is a continuous variable, and taking values between 10 to 20. Okay, so let's take a random like an arbitrary value. Suppose it is 35. So an infinite number of points are there. Okay, and if all the points are equally likely, then what will be the probability for occurring 35? Okay, let's suppose there are, for instance, we suppose that there are 10,000 points are there between 10 to 20. Okay, 30 is one out of those 10,000 points, right? So this probability will be 1 by 10,000, right?
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
Okay, and we know that so many data points are there, so many values are there between 10 to 20. Okay, so it's a suppose it's 1 lakh, okay, or very large number. So then this probability will be approximately zero, right? 0.00 something.
Yes,
Yes.
ma'am.
So now you can get some idea about why the probability at a point is zero for continuous variable, right?
Yes,
And there is
ma'am.
a
Yes,
mathematical
ma'am.
proof
So,
also
yeah.
that we will see after a few minutes how we can show this thing. The probability at some point is zero for a continuous variable. We will see it. Okay, so these were the things about basic things for continuous and discrete variable. Now, first of all, you have studied probability mass function. So what do you understand by probability mass function? So in short, we call it as PMF. So yeah, what do you understand by it? So here you can see that this is also a PMF. What does PMF tells you?
This is
Anyone?
Occurrence of the particular point or the particular thing in
Yeah,
probability.
so PMF basically gives you the probability of each possible outcome, right? So here you can see that outcomes are 1, 2, 3, 4, 5, 6. So the probabilities are 1 by 6 for each of the outcome. So basically, by probability mass function, we get to know about the probability of each possible outcome. Right? So yeah, this is the example we have seen. What are the properties for PMF?
Sum of the all the probabilities equal to 1.
Okay, and other one?
is always between 0 and 1 probability of it.
0 and 1. Yeah.
Yeah, so the probability of any event is always greater than or equal to 0, right? And the summation of all the probabilities, okay, that should be equal to 1, right? So these are the two properties for PMF. Okay, now what is CDF?
Cumulative distribution.
Commutative
Okay, so it is a cumulative
Distributive
distribution
distribution.
function. Right? So what it does, it accumulates the probabilities up to a certain point, right?
Yes.
Okay, so it accumulates the probabilities up to a certain point. And how we can represent it mathematically? Okay, so it is probability that x is less than or equal to some point x, right? Or if you are taking the point as a, you can write it like this, that probability x is less than or equal to some point a, right? So this is the CDF at point A. So what it does, it accumulates all the probabilities up to the point A. Suppose this is a real line and this is the point A. Okay, and the PDF starts from this point. So the summation of all, like integration of all these points, the probabilities up to this point, right? Okay,
Yes.
and CDF, it is a function from real value to this interval 0, 1, right? Is it clear?
Yes.
Why so? Okay, so you can see that where a, which can be any real value, right? And when you put this value into this function, okay, the value you will get for CDF will always lie between 0 to 1, right? So there are some properties for CDF also. Okay, so the first one is that CDF is always a non-decreasing function, right? Fx is a non-decreasing function. So what do you understand by non-decreasing function?
It's basically if the function is taken value 1, then it cannot take the value 0 if it is in continuous.
Continuous increasing, we can say basically. A value will be not going to the first, like below to the origin value, and it will be only increasing way.
Okay, so what will be the difference between non-decreasing and increasing?
Non-decreasing things, it means like we can just fix a value, and our function will take the value either that point or above the point, not below the point.
Yeah.
It will be not
So
going to decrease.
non-decreasing means either it can be increasing or it can be the same value at that point, right? So maybe suppose the function is like this. So either it can be like same for 2 points or it will be increasing only. Okay, it cannot decrease. Either it can be same or it will be increasing, right? And if we write it as increasing, then it cannot be same for any 2 point. Then it will be increasing only in that case. Okay, so that's why it is a non-decreasing function and not a increasing, right? So we can see this thing through an example. So suppose we have a variable x, okay, which is following uniform distribution. Okay. Okay. So now what will be the probability at point 1?
1 by
Point
5.
two.
1 by
Point
5,
1 by
right?
1/5. Yes, ma'am.
Okay. And for x is equals to 2 also, right? 1 by
Yes.
5 up to x is equal to 5. It will be 1 by 5 only, right?
Right. Yes.
Okay.
Yes.
Now, if I have to find the probability that x is less than or equal to 3,
Cumulative.
So
so
we'll go
how,
from 1 to 3.
1, 2,
yeah,
3.
so it will be the summation of probability at 1, 2, and 3. Okay, so here it is a discrete variable. So it will be probability x is equal to 1 plus probability x is equal to 2 plus x equals to 3. So it will be 1 by 5 plus 1 by 5 plus 1 by 5, right? So this will be 3 by 5. Now, if I have to find, yes, hello.
Yes, ma'am.
Okay, now if you have to find probability x is less than or equal to 4, then it will be summation from 1 to 4, right?
Yeah,
Yes.
1
Yes.
to 4.
So it will be 1 by 5, 1 by 5. So it will be 4 by 5, right?
Right.
So it is 4 by 5. Now, if we have to find probability x less than equal to 3.5, then what it will be?
Up to 3, ma'am.
3.
Yeah.
Okay, so we can write that probability x is equal to 1 plus x is equal to 2 plus x is equal to 3 and plus probability x is equal to 3.5. So for 1, 2 and 3, we know the probabilities, right? Because the random variable is taking values 1, 2 and 3 with probabilities 1 by 5. Okay, so we can write that it is 1 by 5, 1 by 5 and 1 by 5. What will be probability x is equals to 3.5?
0.
0.
It will be 0, right? Because random variable is not taking value 3.5. It is a discrete variable.
Yes.
Okay, so now you can see here, okay, so this will be 3 by 5. So here you can see that at point 3, okay, so this is nothing but the CDF at point 3, right?
Yes.
And this is CDF at point 4. And this is CDF at point 3.5, right? So we can see here that point at point 3 and 3.5, the value of CDF is same, 3 by 5, right? And for 4, it is 4 by 5, which is greater than 3 by 5, right? So now
Yes,
I
ma'am.
can write that fx at 3 is equal to fx at 3.5, CDF at 3.5, and it is less than CDF at point 4. So now you can see this thing that why the CDF is non-decreasing. Okay, so either it can be same for 2 points, right? CDF at 2 points can be same, or it will be increasing. It cannot be decreasing. Okay, now is it clear? What does it mean that fx CDF is a non-decreasing function,
Yes, ma'am. Crystal
right?
clear.
Yeah. Okay, so this was the one property of CDF. Now the next one is, so as x tends to minus infinity, fx goes to 0, right? And x tends to plus infinity, then fx goes to 1. So basically, it means that the range of CDF, okay, it belongs to 0, 1, okay? So both 0 and 1 are included, right? Is it clear? Okay, so suppose we have some variable, okay, which is taking values a, b. Okay, we have a random variable, continuous, or any random variable which is defined between a
Ma'am,
to b.
would you mind explaining this point once again? Sorry.
Yeah, I am
Yeah.
explaining this thing only.
Okay.
Okay, so what does it mean that we have a random variable which is defined in this range, a to b. So if you take any point below this, below the lower limit, okay, suppose we are taking minus c. You can take any value. Okay, here minus c is less than a. Okay, or any value which is below a. So if you calculate CDF at minus c, what will be this value? 0, right? Because the function is defined only in this range. Okay, let's take some real values. Okay, suppose the range is from 5 to 50, suppose. Okay, so if you take any point below 5, suppose we are taking CDF at point 3. So it will be 0, right? Because there is no point below 5, because the function is defined in this range only, 5 to 50. So the probability below these points, below 5, will be 0, right?
Yes.
Okay, and if you take any point which is greater than 50 here, okay, so you know that at this point the CDF will be 1, right?
1.
because we have added all the probabilities, okay, which are defined for this PDF or PMF. Okay, it's a general case. It's for both continuous and discrete variable actually. Okay, so if you take any point which is above 50, suppose it is 100, okay, then it will be 1 only, because up to that point, if you add all the probabilities up to this point, it will be 1. Okay, now if you add, so we can write it like this. Okay, this will be 1. Now if you have to find fx at 100, okay, so it will be like up to this point 50, then we can add the point which are above it. Suppose it is 51 or 52 or any point. So up to this point CDF is 1, and these probabilities will be 0, right? Because the variable is not defined here. So these PDF or PMF will be 0 in that points. Okay. So if you take any point above the upper limit, okay, or to which the variable is defined, it will always be equal to 1 only.
Ma'am,
Now
this will
is it
happen
clear?
in case of continuous, right?
It is for both actually. Okay, so the range of CDF is 0 to 1. Either it is a continuous variable or a discrete variable.
Ma'am, if you are like calculating the probability at a specific point, here you say for fx for equal to 100, basically, right? So 100 is not defined here. X is not taking the value as 100. So how can we say that fx 50 will be concluded in this?
Yeah, that is okay. See, I am saying that this is what? This is the CDF at point 50, right?
Yes, ma'am.
Okay, and I am taking a particular example where X is defined between 5 to 50. Okay, so this is the last point, right? So at this point, the CDF will be 1, right?
Yes, ma'am.
Because we have added all the probabilities. Now, if you take the point which are above this point, suppose this is 100. So we know that these points after 50, so there our random variable is not defined actually. So their probabilities will be 0, right? So if you take probability at point 51 or 52 or any point,
Yes, ma'am.
okay, or either you can take, if you're talking about a continuous variable also, if you take some intervals, then also because the variable is not defined in this interval, it will be 0,
Yes, ma'am.
right? So it will always be 1, because we have to add 0 only. So if you take any point which is above the upper limit where the variable is defined, it will always be 1. Okay, similarly, if you take the point below this, below 5, which is a lower
Yes.
limit for the random variable which is defined. Okay, so that will be 0 again, because the random variable is not taking values here, right? So
Yes,
it
yes,
will
ma'am.
always be 0.
It's clear, ma'am.
Now, is it
Thank you.
clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Now the next property is, so if we have to define probability A, a random variable A is taking value A to B. Okay. B here is included and A is not included. So how we write it generally? We write it like this: CDF at point B minus CDF at point A, right? So we can see it on the real line. Suppose this is some point A and this is some point, any point B. Okay, so if you have to find this probability A to B where A is not included but B is included, right? So how can we write it? So what do you understand by CDF at point B? So this will be like up to this here, right?
Yes, ma'am.
Okay, and FA will be like up to this point.
Yeah, hollow
Okay,
circle we can say.
so if you Now, if I like subtract this part, we will be left with this part only, right? Okay, so up to A we have excluded. Now after A and up to B, right? So this will be the probability, like A and B. Okay, so A we have excluded, right? Because up to
Yes,
A,
ma'am.
you can see here, if I talk about the CDF at point A is also included, right? So up to A, we have excluded this probability. So now we are left with only this part. After A, okay, X is greater than A, okay, and up to B. And B is included. X is less than or equal to B, right? So now you can justify this thing that probability X is taking values A to B is equal to CDF at point B minus CDF at point A.
Yes, ma'am.
Okay, is it clear to everyone or any doubt?
No, I'm clear.
Okay. Now, if I talk about the discrete case particularly, so again, I am writing the same formula. And this is nothing but the probability X is less than or equal to B minus probability X is less than or equal to A, right? These are same, right?
Yes.
Yes, ma'am.
Yes.
Yes.
Okay. So if I talk about discrete case, now, okay, so this is one formula. Okay, now if I have to find probability. Okay, so what's the difference between these two? Here you can see A is not included. Okay, but here A is included. So how can we write this probability using this formula? First one. So it will be like probability A to B. Now what should I add here to balance this equation?
Probability at point A
Plus probability of
probability of A.
Plus probability that X is taking value A, right? Now these two are same, left hand side and right hand side, right? Now similarly, if I have to
Yes,
find,
ma'am.
so now if I have to find that this one, okay, where both A and B are not included. Okay, now how should I write this one using this part?
PA less than X, X, yeah, X less than equal
Okay,
to B
this thing I have written. Now what should I add or subtract?
Minus
PX equal to
probability
PX
X is
equal
equal
X is equal to
to B.
B.
Yeah.
B.
Okay, now you can see it. Okay, so here A up to B. Now we have excluded this probability. Okay, similarly, one more case will be there. So now, how can I write this?
Probability of A
Yeah.
plus P of X equal to B. X equal A.
So we need to add probability X is equal to
To
A.
A. Plus
and subtract probability of
Minus
Plus
probability
PX
X
equal
equal
to
to B.
And
equals to
minus
PX
X is
Probability
equal
X
to
equal
B,
to
right?
B. Yes, ma'am.
Okay. So now we can see these are the four results for a discrete variable. So we need to remember only one point. If you remember only this point, you can find all the other three values, right? Okay, so you don't need to mug up all these formulas. You just understand one point and you can solve all the other. Is it clear to everyone, these points, these probabilities?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
But ma'am, in the first case which you have told us to remember, In this case, no. For discrete,
Yeah.
P of x less than b minus P of x less than equal to a. So in that case, you are subtracting P of x less than equal to a from P of x less than equal to b. Why you are doing like that? Because you can only subtract a P of x less than a.
Can you please repeat your question?
Why you are subtracting from P of x equal to x less than equal to b minus P of x less than equal to a.
Okay, so let's again understand this thing through this figure. Okay, do you understand this figure? So
Yes.
suppose this is point A and this is B. What we have to find? We have to find this region. We have to find this one, right? What is the question? The question is to find the probability between A to B, and B is included, but A is not included, right? So what we are doing, so probability X is less than equal to B, what it is? It is the CDF at point B, right? And X is less than or equal to A, it is the CDF at point A, right?
Yeah.
So here, yeah, okay, so suppose like this is the lower limit if in case, okay, so randomly we have taken 2 points A and B. So if you have to find the CDF at point B, you have to add these probabilities up to point B, right? Okay, so this is your fx at point B. Okay, this line. Can you please mute your mic? Please mute your mic.
Please mute.
Okay, so the first red line will be your CDF at point B, right? And the second line is representing the CDF at point A, right? So because here we are adding the probabilities up to point A. Now what we are doing here, we are subtracting.
Ma'am, can you mute him?
Mute all.
1 minute. Yeah, now screen is visible, right?
Yes, ma'am.
Yeah. So now what we are doing, we are subtracting the CDF of A from CDF at point B. So if you exclude this line, so we will be left with this part only, right? After A. So A will not be included because up to CDF, up to point A, we have added all the probabilities, right? So this will be after A and up to B, right? If you look into this figure carefully, you will understand this part. Are you getting my point?
Yes,
So
ma'am.
this
Done, ma'am.
green part is like whoever is asking this question. Did you understand?
Yes, ma'am.
Okay, so this will be the probability A to B. So B will be included, but A will not be included here. Okay, so this is for the discrete variable. Okay, now if you talk about the continuous variables, so we know that for continuous variable, probability at point is 0. Okay, so why probability at point, suppose it is A is 0 for continuous case. So if we have to find this probability, this one, for a continuous variable, so how we find it? we just integrate the PDF up to these limits, A to B, right?
Yes, ma'am.
Okay, in this way only we can find this probability. Okay, so this is actually the area. So suppose this is A and this is B. Okay, so this is this area. This area will be represented by this probability. Okay, now if I put A again in place of B, okay, now it will be like this line only. So we
Yes,
have
ma'am.
to calculate the probability at this point A only. So this is just a line. Okay, and there will be no area for a line. And if I write it mathematically, it will be from A to A fx dx. So if you integrate this, it will be 0, right?
Yes, ma'am.
So
Yes.
mathematically also you can see, and if you think about it, so there is no area for line. Okay, because line is 1D, so we cannot calculate the area for a line. Okay, so you can see now that all these probabilities, so here you can see that if we have to calculate this part, okay, this will be 0, right? So it will be equal to this part only.
Yes,
Yes
ma'am.
or no?
Yes, ma'am.
Okay, now
Yes.
here also this will be 0, probability
Mhm.
x is equal to b. Now again this thing will be equal to this part, right? Okay, similarly for the last one also. So these both, probability x is equal to a and probability x is equal to b, this both will be 0. So now this probability will be equal to this part, right? So for continuous random variable, we can conclude that this thing, that probability, this where a and b are not included, okay, will be equal to this one, will be equal to this one, right?
Why it all?
So for continuous variable, all these part will be equal to each other. Why? Because the probability at point will be 0 for a continuous variable. Is it clear to everyone?
For
Any
Yes, ma'am.
question, any doubt in this
for
part?
madam, you are saying that for a particular point, all these inequalities are equal.
Your voice is very low, actually.
Hello, am I audible?
You are audible, but your voice is very low.
I'm saying that for a particular at a particular point, all these inequalities are equal.
So these probabilities will be equal for continuous variable. Okay, I'm writing all these things for a continuous variable.
Okay, but
Okay, if you talk about discrete case, these are the probabilities.
continuous variable means CDF, na?
Okay, do you understand what is discrete, what is continuous variable, or what is PDF, what is CDF? Not PDF at least.
I understand that what discrete and continuous variable, but I'm thinking that discrete is same as continuous CDF.
CDF is something else. Discrete variable and continuous variable are the types of variable. And CDF and PDF and PMF are something else. Okay, don't get confused with continuous and CDF. Okay, CDF is just a function which accumulates the probabilities. Okay, this is the property like how we define the CDF. Okay, and we can define CDF for both continuous and a discrete variable. Okay.
Okay.
So this is the probability. 1 minute. Yeah, these are the probabilities for discrete case. Okay, and if we put probability x is equal to a is 0, x is equal to b is 0. Okay, which are true in case of continuous variable. Okay, then in that case, these inequalities will be equal to each other. These probabilities, sorry. Now, is it clear?
Yes.
Okay. Okay, let's take an example and see the graph of CDF. So suppose we have a random variable x, which is again uniform, and taking the values 1, 2, 3, 4, and 5. Now, if I have to draw the graph of this the graph of CDF of this variable. Okay, so this is 0, this is 1, this is 2, this is 3, 4, and 5. Okay, and the probabilities were 1 by 5 for all the points, right? So 1 by 5, 2 by 5, 3 by 5, 4 by 5, and 5 by 5 will be 1, right? Now, if I have to draw the graph of CDF, so we know that below 1, the probabilities will be 0, right? Okay, and at 1, it is 1 by 5. So we can draw the graph like this. Okay, and point 2, probability is 2 by 5. So it will be like this. So you must have studied these things in statistics 1 course, if you remember.
Yes, ma'am. It will behave like a step-up function, something.
Okay, so
Greatest integer function, mathematics.
Yeah, sorry. Yeah.
okay, in this. So at 5, it will be 1, and 1 for the points above 5 also. Okay, so in this way, we make the graph of CDF. Now, from this graph, we can find the probabilities also, right? If you are given only this graph and you don't know about the probabilities of that x takes value 1, 2, 3, or 5, 4, or 5. So from this graph also, you can find it. So you can see that the jump. Okay, so if you have to define the probability at point 2, what it will be? It will be the jump, right? The jump in this graph. So it will be 2 by 5 minus 1 by 5, right?
Yes.
So this will be 1 by 5. Similarly, if we have to find the probability at point 3, it will be this jump. So it will be
So, ma'am, the
3
particular
by 5.
in particular point, the jump should
Hmm.
be considered at the probability of this point.
Yes, for discrete variable.
Hmm.
Okay, so the graph of CDF is made like this. Okay, so these jump represents these the probability at this point.
Yeah.
Okay,
Hmm.
so for each point in this particular example, you can see it is 1 by 5. Okay, so if you have to find for 3, it will be like this thing, 3 by 5 minus 2 by 5. Okay, so again it will be 1 by 5 only. So these jumps represents the probabilities at the point. Okay, and you can see that you can find the jump at 1, 2, 3, 4, and 5. So you can see this thing that this particular random variable is taking value 1, 2, 3, 4, and 5. Okay, and it will not be taking any other values. Can you see the jump at any other point? No, right?
No. No.
Okay, so like these information you can get from the graph of CDF. Okay, so from the CDF, this graph, you can see that the random variable is taking, suppose this information is not given to you. Okay, just look at this graph. Now
Ma'am,
you can see that the
ma'am,
jump is at, yes.
at x equal to 1 also, isn't it taking a jump?
Yeah, so it will be, okay. So for x is equals to 1, it will be
1 by
1
5 minus.
5 minus 0. Okay, so because below, like here also I have drawn a line.
Understood.
So below 1, it is 0, right?
Yes. And similarly for x equal to 4, it will be 4 by 5 minus 3 by 5, basically.
Yes. Okay. So we can see the jump at 1, 2, 3, 4, and 5. So these are the points taken by the random variable, and these jumps represents the probabilities at this at like corresponding points. Okay, so this is the just example for discrete variable. Okay, let's take another example. So if we have a random variable, okay, so in the example when the values were 1, 2, 3, 4, and 5. Now if I take 1, 2 up to suppose 100. Now if I draw the graph, so it is like 0, 1, 2, 3 up to 100. And the probabilities will be like 1 by 100. This is 2 by 100 up to 1. 100 by 100, 1, right? So now if I draw the graph, so below 1 it is 0. This is 0. Then this one, right? Then this, like this will be close to each other, right? In this way, right? Okay, now again, so it will go up to this point, 1, right? Okay, now if I increase the number of points again, suppose now we have 1, 2, up to suppose 10,000. Now if I draw the graph, so this is 0, the points will be very near to each other, right? And this is 10,000.
It will be difficult to draw.
Yeah, that's why I'm trying to show you. So it is 1 by 10,000. Okay, and here it will be 1. So now if you draw the graph, okay, so this will be very near to each other, and okay, it will be like this, right? So here you can see that it starts behaving like a continuous line, and to find the jump is very difficult. It's like impossible, right? So the graph will be like this. So you can assume that like this is a continuous line, right? So for discrete, the graph of CDF is like this. So it is like the jumps you can find in the graph of CDF for discrete random variable. But if we have continuous variable, we can see a lots of points will be there. So the graph of CDF will be continuous in this way. So now if I if I ask you to find the jump at some point, suppose 100, can you give me what will be the jump? It will be 0, right?
0.
Yes, it will
Yes.
be 0, right? So
At
you
a
can
point.
see that. So again, you can see this thing that the probability at point 100 will be 0, because how we find the probability? By the jump, right? And there is no jump because the data points are very tightly clustered. Okay, so it becomes a continuous line in this case. So here the jump is negligible. So the probabilities at the point will be 0 for a continuous variable. Okay, so now you can see that here a lots of points are there. So it becomes like, it behaves like a continuous variable. Is it clear to everyone?
Yes, ma'am.
Okay. So now you can see that now we move on to the probability density function for a continuous random variable. So we have, up to this point, we have seen the PMF. Okay, then we have CDF. So these for two discrete variable, right? Now we have seen CDF, okay, for continuous variable. This one, right? Now we will see the PDF. So this CDF like works like a bridge between the discrete and continuous variables. So now we will see about the what is the probability density function. So if I talk about the formal definition of probability density function, it is a continuous random variable with CDF fx is said to have a PDF fx, small fx is for all x naught so it will be minus infinity to x naught fx. Okay, so you can see that for discrete we write the probabilities like x is less than or equal to a. So for continuous, we integrate the PDF up to that point, the point at which we have to find the CDF. So this is for the continuous random variable. Okay, and from minus infinity something. So here, like the lower limit you have to take. Okay, so suppose your random variable is defined between a to b. Okay, and between a to b, suppose we have some point, suppose d, and we have to find the CDF at point D. So we have to integrate the PDF, right? And what should be the limit in that case?
A to D.
A to D, right?
A to D
Because up to D we
plus
have
D
to
to
find,
D.
okay, and the lower limit, okay, like from A, our random variable starts. So the lower limit will be A. Okay, so basically it is like, so if you have some, suppose this graph, and this is some point x naught. Okay, so this area. Okay, so this is your CDF at point x naught, right? So here you can see in this statement, you can see that CDF is the integral of PDF. So whenever we have to find the CDF for a continuous variable, okay, what we do, we integrate the CDF. Oh, sorry, integrate the PDF. Okay, and we can inverse this thing also if you are given the CDF. Okay, CDF is given to us, and we have to find the PDF. So what we can do, we can differentiate this thing. We will differentiate the CDF and we will get the PDF. Do you understand this thing?
Yes,
Yes,
ma'am.
ma'am.
Okay, so you can see that if you integrate it, just to verify this thing. Okay, so integration and both differentiation at the same time. So that will be equal to fx only, CDF, right? Okay, so if you have to find CDF from PDF, you will integrate the PDF. And if CDF is already given to us and we have to find PDF, we can differentiate the CDF. Okay, and don't get confused by this thing that capital F is something that represents CDF, and a small fx is something that represents PDF. Okay, so don't get confused by this notations. Okay, so what do you understand by the probability density function? Any idea? Any guesses?
So, ma'am, CDF is the differentiate value of the PDF, we can say. After performing the derivative of PDF, we can find out the.
So if you differentiate the CDF, you will get the PDF.
Yeah.
Yeah. Okay, so what do you understand by PDF? Any idea?
Like in the continuous random variable of x from which the probability of x is obtained in a range which is given in the interval, given interval.
Okay, anyone else?
So probability density function.
Hmm?
Probability density function.
Yes. What do you understand by it?
That is
Basically,
integrated through all A to. Suppose we want to calculate the probability from A to B. Then we integrate this PDF from interval A to B.
Yeah, it's correct.
Yes.
Okay, so basically what we try to find in case of continuous random variable, suppose this is some PDF, this is some curve, and this is the A and this is B. So what we try to find, we try to find this area between the point A to B in this case. So what we do, we just integrate the PDF over the range. Okay, so basically the value of fx indicates, so it just indicates that like how densely the probabilities are packed around that point. Okay, so if the value of fx is higher, so we can say that around this point, x is most likely to occur. So what do you understand by density actually? So density is equals to mass divided by volume, right? So it represents the mass per unit volume actually. Suppose you have some like okay, so you have some volume here. Okay, so density tells you the mass.
Mass by mass upon unit volume.
Okay, mass per unit volume.
Yeah.
Okay, so you can like same analogy you can use here also. So if fx is high, okay, which means the probability density function is high, which means that the x will be taking most of the values around that point x.
So, madam, can we call it probability per unit length? Probability per unit length. In the lecture was said probability density.
By length.
Suppose we draw the PDF of a curve, then we say that it is more than it is per probability per unit length, and it can go more than one, something like that.
Okay. Okay, so basically it just tells you about how likely the x is to take the values around that particular point. Okay, but it is not probability, it just gives you an idea about like it's a density. Okay, now do you understand Do you have some idea what do you like what probability density function tells us about the random variable? So okay, if I write, so it is basically okay. Now read this line and try to understand. Okay, so high value of high value of fx, which is the PDF, will indicate that x is most likely to occur around that particular point at which you are calculating the PDF. Okay, so basically, we in continuous variable we talk about the in the interval. Okay, we more focus on the interval and not on a single point. So basically, it gives you the area if you are like here. Okay, here you can see if we are calculating the probabilities between A to B, so it will give us this area. Okay, so this is the curve fx, the PDF, and these are the points in between we are trying to find the probabilities. Okay, is it clear to everyone? Also, this PDF function is from real to real.
Ma'am, so like
PDF.
when we are saying that how densely probabilities are packed, so it's likely that how often the random variables are likely to take the values, right?
Yes. Like the chances that x is
Of the
around this point. Okay, so
axis.
suppose we have this point. Suppose this is the x. Okay, this is fx. So we can see that around this point, most of the data points will be there. So this is like density is high around this point. So we can talk about the small interval. Like if this is some point x, then we can take the small interval x plus delta and x minus delta. Okay, so here the density is high. So we can say that most of the data points lie around this line. Now, do you get some idea?
Yes, ma'am.
Okay, yeah. So this is the PDF. Now the properties of PDF. So we know the properties for PMF. Similarly, we can find, we should know the properties of PDF also. So fx should always be greater than or equal to 0. Okay. And if you integrate this PDF over the range, okay, onto which the random variable is defined, so this should always be equal to 1. Okay, so suppose if your random variable is defined between some point C to D. Okay, so if you take integration over C to D, the entire area will be equal to 1. Okay. So these were the two properties of PDF. Now, what is the support of X? So support is nothing but the values taken by the random variable X. So support of random variable X with PDF fx is okay, so it is the values of x such that fx should be greater than 0, greater than or equal to 0. Okay, so you see, it is basically the range of x. Any question? Okay, so these were the things for continuous variables. Okay, now we have some common distributions for continuous variable.
So support of x is basically the range of x.
Yeah, the values that x takes. Yeah.
X can take. Okay.
Yeah. So the first one is uniform distribution. Okay, so we have a random variable x which is taking which is following the uniform distribution over the range a to b. Okay, now what will be the PDF? So these distributions like uniform, exponential, normal, you have studied all these things in your statistics 1 course also, if you remember. So anyone knows what is a PDF for uniform distribution? The range of x is
1 upon b minus a.
yeah 1 upon b minus a and 0 otherwise, right? And what will be the CDF? So if you remember the CDF, it's good. Otherwise, you can use the formula of CDF and calculate the function. So in case of uniform, the CDF is, so it will be 0 if x is less than or equal to a, and between a to b,
X minus a upon b minus a.
yeah, x minus a divided by b minus a. Okay. And when x is greater than or equal to b, it will be 1. Okay.
Ma'am, so in this case, like we can integrate the PDF and also find the CDF, right?
Yeah, sure. Okay, let's see how we do that. Okay, so if you have to find the CDF at some point, suppose x only. So what you can do? So what is a lower limit? Okay, you can see that here uniform is defined over the range a to b. So what should be the range here?
0 to a.
0 to a. Why?
We are finding at a, right?
Okay, we are finding out at x.
Oh, x. Sorry.
Okay, this
Ma'am,
is the
A
point.
to B. A to B is the limit, I think.
We have to find CDF at point x.
At point x, so it should be
Minus
Minus
infinity to
infinity
x.
to
Minus infinity to x.
minus infinity to plus infinity.
Okay, so see, minus infinity to plus infinity we write in general. Okay, but if we are talking about a particular distribution, you have to see what are the lower limits and upper limits for that particular distribution.
If
So
you
here
take
you can
if
see
you
that
take integral 0 of dx, then it will be minus infinity to a. If you take
yeah,
the x minus a by b minus a, it will be a2 x
so it will
and
be okay, you can write from minus infinity to up to point x, right?
yeah.
That's
Yes.
the point. Okay, we are finding it out for the value x. Okay, so this limit will be x only. Now you can further divide it. Okay, so we know that x is defined from a to b only, from a to b. So, and suppose here is something, it is minus infinity. So from minus infinity to a, so we have to break these integration limits. So it will be this. Okay, and then from a to x. Okay, now you can see that from minus infinity to a, fx will be 0. Okay, so this is the distribution you can see from a to b. The PDF is 1 upon b minus a and 0 otherwise. So if x is taking values other than these, okay, if it is taking value like x is less than a or x is greater than b, then it will be 0. So here we can see that this PDF will be 0. So if you integrate 0, it will be 0 only. Okay, now here it will be a to x, and what is the PDF? It is 1 upon b minus a, right? Now if you integrate it, it will be 1 upon b minus a and x, a to x, right? If you are getting confused with this x, so you can take some other point also, but generally we take it like this, so I have taken x. Okay, now if you put the limit in x, it will be x minus a, right? Is it clear to everyone? Any doubt? Hello?
Yes, ma'am, it's clear. It's clear.
Yeah.
Hmm.
Okay, so it will be x minus a divided by b minus a. Okay, for this range. And we know that we have seen this thing earlier also, like above b it is always 1 and below a it is always 0. Means above the upper limit, okay, it will be 0 and at this point, and below the lower limit the CDF will be 0, right? This thing
Yes,
I
ma'am.
have explained earlier also. Okay, now next distribution that we have is exponential. So what is the PDF for exponential distribution?
Lambda exponent minus lambda x.
Okay, so x is following exponential distribution with parameter lambda. Okay, so the PDF in that case, it will be lambda e to the power minus lambda x. Okay, and the range, what is the range for x or support?
Greater than 0.
Yeah, x should be greater than 0. Okay, and it will be 0 otherwise. Okay, now if I talk about the CDF, so the CDF is, so if x is less than equal to 0, it will be 0. And for x is greater than 0, it is 1 minus e to the power minus lambda x. Okay, so let's integrate it again. This one also. So now what should I write for the limits?
Minus infinity to lambda.
Okay, minus infinity to lambda. So now if I have to break the limits, then okay, first of all, why it would be lambda here, upper limit? It should be x, right? Not lambda.
X.
Okay, it will be x, not lambda. So
Ma'am,
now you can break it down.
Not lambda.
Yeah, sorry. Okay, so from minus infinity to 0 it will be, because the values that x can take starts from 0.
Ma'am, one second, show the chart again to confirm the limit. Yeah, x, not lambda, ma'am. Okay.
Okay, so we know that from minus infinity to 0, it will be, the PDF will be 0. So now I can directly write it from 0 to x, right?
Yeah.
Yes.
So now we can write like this. Okay, so from 0 to x, we have to integrate the PDF lambda e to the power minus lambda x.
Ma'am, we can write this thing in some different way. That suppose you are taking this integration, in place of we can write the minus integration minus infinity to 0 dx plus 0 to infinity lambda e power minus lambda x dx. Then it will
Yes. So
simplify.
we can write it like this also, minus infinity to 0, okay, limit, and then
Okay.
0 to the
Yeah.
point at which we have to find the CDF. Okay.
In this way we have taught in the lectures.
Yeah. In this way, you have to write. Okay, because this part will be 0. That's why I have not written it here. Okay.
No, but why you limiting this up to x? It should be infinity, na? Positive infinity.
See, we have to find the CDF at point x only. Okay, so the variable is defined from 0 to infinity, but we have to find the CDF at some point x. So we just have to accumulate the probabilities up to this point only.
Oh, you are telling f of x of x equal to p of x equal to x.
If you are getting confused with this x, we can take it as a. Okay. Okay, let's take it as a. Don't write x. Suppose it is a. Okay, now we can write minus infinity to 0, then 0 to a. This is some point a.
Yeah.
Okay, now is it clear?
Yeah, clear. मतलब कि जिस पॉइंट में निकलना है उस तक ही जाएंगे हम माइनस
Yes, yes. Yeah. Okay, so we have to find up to point A only. So we will add up to A because we are using, we have continuous variables, so we have to integrate it. Okay, so now from 0 to A, lambda e to the power minus lambda x. Okay, now it will be lambda e to the power minus lambda x divided by minus lambda, right, from 0 to A, right? So it will be lambda divided by minus lambda. So this will be e to the power minus lambda. Now you have to put the limits. So it will be lambda a minus e to the power lambda into 0, it will be 0, right? So this will be minus 1 and e to the power minus lambda a minus this will be 1, right? E to the power 0 will be 1. So now it will be 1 minus e to the power minus lambda a, since we are finding out the CDF at point A. Okay. So here I have written that fx, okay. So that's why it was 1 minus e to the power minus lambda x. If we are taking a, if you are finding out the CDF at point A, it will be 1 minus e to the power minus lambda a. Now is it clear?
Yes, ma'am.
Okay, so it was for exponential and uniform we have seen. Next distribution is normal distribution.
Ma'am, there is something left. The memoryless property of exponential, the same as
yes.
Something is given in the textbook that I have noticed. Memoryless property of exponential. It is same as the previous memoryless property which we have learned. No?
Yeah. The property is same. The both geometric and exponential follows the memoryless property. Okay, so the third distribution is normal distribution. Okay, so if x is following normal distribution with mean mu and variance sigma square. So do you remember the PDF for normal distribution? So it is 1 upon sigma under root 2 pi e to the power minus 1 by 2 x minus mu divided by sigma whole square.
In stats 1 last lecture it is.
Yes. Okay, and the range is from minus infinity to infinity. So this is the PDF. And CDF, so for normal distributions, there is no closed form of CDF. So you can just simply integrate this. Okay, and you can find some value for CDF. But there is no closed formula. Like we have this formula for exponential and this formula for uniform, but we don't have any closed form formula of CDF for normal distribution. Okay, now let's solve one example. Okay, so this is some PDF given to us. is 3k and 0 otherwise. Now you have to find the value of k, okay, such that fx is a valid PDF. Okay, now you all solve this question.
Ma'am, it is 0 to 1 by 4 or 2 by 4?
Yeah, it's 1 by 4.
Okay.
0 to 1 by 4, then 1 by 4 to 3 by 4, then 3 by 4 to 1. And next you have to find the probability x is greater than 1 by 2. Okay, now you all solve this question. Try it.
Ma'am, some background noises are coming.
What?
Some background noise is coming.
Okay, okay. Okay, you solve the question and let me know. I'm waiting for a few minutes. Okay, anyone done that question?
Ma'am, first part is solved, second solving.
Okay, what is the value of k?
1 by 2.
Okay.
Oh.
The second answer 5 by 8. No?
Okay. Okay, now I am solving this question.
Okay.
Yeah, so answers are correct.
Half
So
and 5
the
by 8.
first
Right?
part. So the PDF is defined as like from 0 to 1 by 4. This is the value. Then from 1 by 4 to 3 by 4, this is this one 2k. From 3 by 4 to 1, this 3k. So we have to find the value of k. So we can use this property that the summation of this CDF over the range of x, it should be equal to 1, right? Now the x is defined from 0 to 1 by 4, then from 1 by 4 to 3 by 4, then from 3 by 4 to 1. So this should be equal to 1. Now from 0 to 1 by 4, the PDF is k. So k dx. Then from 1 by 4 to 3 by 4, it is 2k. So 2k dx. Then from 3 by 4 to 1, it is 3k. So 3k dx, right? Up to 1 only the continuous variable is taking the values, right? For other values, it is 0. Now we just have to integrate this and we'll get the value of k. So it will be k and x, it will be 0 to 1 by 4. This will be 2k x over 1 by 4 to 3 by 4. Then it is 3k x over 3 by 4 to 1. So now if you solve it, it is k, it will be 1 by 4 minus 0. It will be 2k, 3 by 4 minus 1 by 4, right? Then it will be 3k, 1 minus 3 by 4. So it will be k into 1 by 4 plus 2k into 2 by 4 plus 3k into 1 by 4, right? So it will be eight k by 4, right? So k will be 4 by 8, which is equal to 1 by 2. Is it clear to everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
Now the second part is we have to find probability x is greater than 1 by 2. Okay, so how did you solve this part?
Can we write this as 1 minus px less than equal to half?
Yeah, we can solve in this way also.
So px less than equal to half, like it will have two parts, right? In one we have k into x and another we have 2k into x. So we
Okay,
can,
yeah. So if you can directly solve it also, x greater than 1 by 2, or you can use this way also. So if you are using x is less than equal to 1 by 2, then you can see you have to integrate for 0 to 1 by 4 first, then
and
from 1 by 4 to 1 by
yes,
2.
correct.
Okay, and you have to subtract it from 1 also. Okay, I am directly solving it. So x is greater than 1 by 2. I'm not taking this one, I'm just directly solving this part. So
Sure.
if we take x is greater than 1 by 2, okay? So 1 by 2, we can see it will fall between this interval, right? So between 1 by 4 to 3 by 4, 1 by 2 will be somewhere here, right? So
Yes.
from 1 by 2, we can break it down from 1 by 2 to 3 by 4 first, okay? And then 3 by 4 to 1, right? This one, this part. Then 3 by 4 to 1. Now we have to see what are the values of PDF in the corresponding ranges. So from 1 by 2 to 3 by 4, the PDF is 2k. And for 3 by 4 to 1, the PDF is 3k. Okay, so 2k dx and then 3k dx. And we have already calculated the value of k. So it is 1 by 2, so it will be 1 only. Then 3 by 4 to 1, so it will be 3 by 2, right? So that will be 3 by 4 minus 1 by 2, we can write it like 2 by 4 also. Okay, then it will be 3 by 2, 1 minus 3 by 4, right? So this will be 2 by 4, oh sorry, 1 by 4. This will be 3 by 2 into 1 by 4, right? Now if you solve it, it will be 5 by 8. Is it clear to everyone? Any doubt? Anyone has any doubt?
No, ma'am, no. It's clear.
No, ma'am.
Yeah, so these were the topics in week 4. So from week 4, we have to start studying about the continuous variable. Okay, anyone has any question, any doubt in any topic that we have discussed today?
Ma'am, on Tuesday also we'll continue with this only with problems or
Yeah, so on Tuesday, we will be having solve with the session for week 4.
Ma'am, on Tuesday, the types of question you are solving, which help us a lot in solving the graded. So if you increase some problems than the previous sessions, then it will
Okay.
be good.
Okay.
Also, ma'am, one thing I have
Hmm.
forgot. Can you share the week 2 PDF which you have taken in our class?
Okay, it's not uploaded on the portal.
No.
Okay. Okay, it will be uploaded on the portal itself in few days. Don't worry about that.
Or today's session PDF also.
Yeah, all the live session notes will be uploaded. So you can find in in
Your
supplementary
class is
content.
over
There is a
for today.
yeah, it's over. If you have any doubt, you can ask. Otherwise, you can leave.
Okay.
Yeah, so all the live session notes will be uploaded on the portal. So like in supplementary content, you will find a section of live session notes. So it will be uploaded there only.
And
Ma'am,
ma'am,
can we please? Yeah.
also I have told Ishan said that to give us the access of download the weekly the practice book PDFs, but he didn't give us the access. So from your end, can you please can you please allow us to download the PDFs?
I'll have to check this. I'm not sure about this thing.
Ma'am, can you please explain about the activity 3? It's putting confusion some of them.
Activity questions.
No, ma'am, the extra activity 3.
Extra activity. So instructions are given there in the portal. You can find the instructions how you have to submit.
But ma'am, it's fine. But inference part that the output we have to mention over there, like what we concluding from the data, basically what we study in the data. So that part making it difficult for me.
Okay, so what do you want to me exactly?
Uh, okay, so for this one, as of now, let it be. I'll just read it once again. Yeah, the
Yeah.
whole documents that.
Yeah, read it once, you will understand it.
Sure. If I have any doubt, and I'll ask in the next session.
Yeah, sure. Yeah, okay, then thank you all.
Thank you, ma'am.
Yeah, thank you. It's a wonderful session. We got some clarity on the concepts and also the derivation part, basically. Thank you.